day to you. This is Anagalactic bringing you a scientific presentation. Now at the outer end of the spectrum, where we prefer to be in astronomy because it's macrospace we're dealing with, not microspace, these are allied, and so one cannot be fully understood without the other. The Einstein field equation, for instance, just considering what it is, what does it say? Well, what it says is quite mathematically intricate. I think we all can concede that. The reasons for the intricacy of the mathematics was due to the problem that needed to be solved. And the problem was not a mathematical problem, because everything in the universe is geometric before it's numeric. That is, we do not perceive numerically. We perceive geometrically. And then we take measurements which rely on numbers. So they're intricately interwoven. But the problem that Einstein was trying to solve was the geometry of gravity. And what he came up with is now, of course, at the top of the list. It rules science. It is considered to be absolutely a standard way of approaching the universe. That is called spaceTime. So that is in fact a geometry. Now what I'd like to begin with today, we want to talk about how we measure things, but in order to do so, we want to have the correct geometric framework so that we understand why we're trying to understand our measurements. In this case, it would be of gravity, but it goes far beyond gravity. But what it ended up showing was a relationship between time and space where they can be considered to be geometrically related. I consider this to be the heart of Einstein's tremendous insight. It's a geometric insight that there is a relationship between space and time. Now we're going to go into a little bit of detail in discussing c, which is light speed, space conceived as distance, and time conceived in a unit measurement for time we call the second. Another aspect of this cosmological model, which is quite difficult to even talk about, is what is space expanding into? And in fact, is that the right way to say it, that space is expanding into something? Well, at this symposium, in the papers that were submitted, to save time, so they could each read the other's papers, and of course that's a lot of work, but that's what they did. They read each other's papers and then responded to what the other cosmologists were saying. And OMG, was that an eye-opener for me. This was, for me, about 12 or 14 years ago that I studied this symposium. They fought like cats and dogs. Each one, these are world-class physicists who were summoned to this symposium on their reputation as being experts on the subject. And I read their replies to each other and then became fascinated and read a lot of their replies to each other. It gets convolute. There were some places where I couldn't quite follow the intricacies of what was being said, but the overall tenor was unmistakable. These men, each and every one of them, I couldn't review them all, but from what I saw, this was a general statistical consensus. They hated each other's guts. They said that the others did not understand cosmological expansion. Some really demeaning terms were used. The cat hair flew. And after that, I can't even speak to what happened after that, because I had seen enough. They don't understand their own model. They don't know what they're saying. They can't define it to themselves. So the reason I bring this up is so that you and I will not feel daunted in confronting the model. Because if it's not understood, even by the experts who back it, then we need to reevaluate the model. Well, that's exactly what I intend to do. But now to complete the previous story about the James Webb Telescope data that has been returned and caused a firestorm, which has not died down. It never will die down. And it was Eric Lerner, although he wasn't alone in this, he's a prominent critic of the Big Bang and has been for years. And don't ever think that these critics of the Big Bang are kooks in any way, although they will be characterized as such, because this model defends itself, and that was the subject of my last 2 lectures. A most interesting social aspect on science, which is not pleasant at all, because you don't want to see the same thing happen that happened between Galileo and the Vatican. That is exactly what's happening right now, and has been for decades. Eric Lerner, Dr. Eric Lerner, a highly respected plasma physicist who runs his own company and is trying to get fusion power. Well known, well accredited. Nobody in their right mind would say that Eric Lerner has no right to comment on the Big Bang. We all as scientists have a right to comment on it. It's just a question of how seriously you can be taken, because you can't listen to everybody. You have to pick and choose somehow, because you only have a certain amount of time and patience. But Eric has been after this for a long time. He wrote a book, he made a movie, a very good movie. It's only an hour long, and you can watch it for free on YouTube. I'll have links if I feel like it, which I probably won't, but you could find it out, Eric Lerner, and find his YouTube movie. Oh, ARP is interviewed, the Burbages are interviewed, all kinds of giant Narlikar is interviewed, Sir Fred Hoyle was interviewed, from archival footage, but it was all put in there to make a case that the Big Bang is absolutely nuts. Well, I wouldn't go so far as to say that. It has some validity of some kind. Well, that's what we want to know. We want to know where this model went wrong in order to salvage what's right about it. But in order to do that, we do have to be sure of the basis of what's being said, which is what? It's redshift, as you know, and if you don't know, just look at the last 2 lectures. It's based on the Doppler interpretation of cosmic redshift. From galactic light, it's a linear relationship, everyone knows it, but the interpretation that's given according to the model of cosmological expansion, that expansion is said to be due to absolute recessional velocity, that the space of the universe is expanding. That is a remarkable thing to say, just out the gate. And you would have to ask, expanding into what? And that's another aspect of the paradox. First of all, it came from nothing. In order to begin expanding, it had to start somewhere. That's considered to be a singularity, which by definition is undefined. It's a form of infinity. And then it expands into another infinity, which has no definition either. So it's based on 2 illogical statements, unscientific statements, but there is a reason for saying it. And the reason is, there is a linear relationship between the redshift of galactic light, for instance, as a marker, and the distance of that object away. Therefore, according to the model, that redshift indicating distance has another piece of information embedded in it. Because if it's redshift, and light acts as a wave, it is assumed that one can apply a well-known theorem of sound waves. And this is called the Doppler shift of sound waves. And very shortly after the discovery of this principle of Doppler shift, you're certainly aware of what that is. And I've given the analogy, the train analogy is well known. We all understand what the Doppler shift of sound waves implies. It implies two shifts depending on the relative velocity of the source. And that applies to sound waves. It's very well known that the frequency is collapsed if the emitter of the sound has a velocity coming toward the observer, that it's called blue shift, but this would be for sound waves in a medium. But conversely, if the sound source has a velocity, a recessional velocity, that has a velocity away from the observer, then the waveform of the sound waves is, instead of being compressed, it's decompressed. That's called redshift. If that can be applied to light, which is a wave, but it doesn't travel through a physical medium, that is a material medium, although we'll get back to that, is space a medium? Without answering that, I just put that out there. For the Doppler shift of sound waves to be applied to light waves, you have to reconstruct for light what happens with sound. Can you do that? You can begin by saying that light behaves as a wave, and very similarly in many respects to how sound wave behaves. This is a waveform. With sound waves, they can bounce, that would be an echo, and there are other similarities with light waves, which also can bounce, that's called reflection. And these waves can actually exhibit other similarities, such as interference. In sound will do this, I believe. It's certainly in a water volume, if you throw a pebble, this is a famous example, the circular waves go out. And if you throw another pebble and the circular waves go out and you see where the waves interact, they show interference, which you're aware of. Does light do that? We have experiments showing that light waves will interfere. They don't always interfere. But they can interfere. So there are some similarities, but as far as there being a medium of compression, which is the basis of the Doppler shift for sound, it must occur in a medium. How do we know that? Sound will not travel in space. There's no such thing as sound in free space. That's well known. Nobody argues that. Although actually there are considered to be versions of compression waves through intergalactic media, but that's gas. There's actually a medium for sound waves, but it's not free space. Free space is, there's nothing in it. It's just empty space. Well, we understand what that is, although it's hard to find. There seems to be some matter everywhere. Even empty space, like halfway between two galaxies or two galaxy clusters, or right in the middle of a void, it's not empty. There are a certain number of ions or atoms or even bits of dust. Per cubic volume of space, it's just way less. But as for there being sound through empty space, that's by definition impossible. Well then, can you say that light can be treated as a sound wave in every respect? Not unless you can prove it. But you could make the assumption, even if it's unproved. That's not science at its best, but it can be tentative for a hypothesis. And if you're willing to say that, which would be the basis of science, or we'd make no progress unless we guessed at some points, the challenge was taken. And it was asserted by those who first noticed that cosmic redshift could be interpreted as Doppler shift, exactly analogous to sound waves in a medium. The question is that correct? Because everything depends on this. It's that simple, but it's remarkable how profound this is, because cosmological expansion is defined this way. The cosmic redshift is Doppler shift. And what Eric Lerner pointed out very, very correctly, his work has not been refuted, although it's hated, is that according to a certain measurement of surface brightness, you can make a statement about the truth or falsehood of Doppler redshift, which is a conjecture, it's a hypothesis. It never was proved, but it was assumed that it was true without being proved. Well, Eric Lerner has shown from James Webb Telescope data, according to a surface brightness relationship established by several men, but Tolman got the name. He got his name attached to it, so it's called the Tolman, and there are various words that follow his name, is really a relationship of surface brightness to, in this case, what that means in terms of the interpretation of redshift. That if the surface brightness follows one pattern, which would be the Tolman relationship, which is known, if the galaxies further and further out do not change surface brightness in a certain way, then your cosmological expansion has been disproved. And that is what happened. And Eric Lerner wrote papers on this, which are being circulated. They have been for years. And we'll see what happens. But he's right. The Big Bang has been disproved. The whole model is shattered. We're going to assume that that is the case. And you may say that hasn't been decided. The modelers definitely say it hasn't been decided. Well, they say it has been decided that Lerner is full of crap and that he's misinterpreted either the data or the Tolman principle or both. But they will never give in. They are biased. They will not discuss it except to just say that it's wrong without dealing with the actual issue. You and I are going to deal with the actual issue, and that'll be in the next lecture later today. Thank you for tuning in. This is Galactic, bringing you the secrets of the universe, currently homing in on the greatest secret of all. We're going to get to the propagation of light in free space, and we're going to study the quantum paradox as it applies to the electron and the photon, and then we're going to get the solution to the quantum paradox. We will have a better model for cosmology, which is, it won't go to the same extent because I am certain that we do not know the origin of the universe, and I doubt that we ever will. But what we can do and must do in science is create a model for astrophysical space. We have to know how things work in the universe. Whether we know its origin or not, we still have to make a model. Currently, we have none, because the current cosmological model is absolutely wrong. That has been proved. This is Galactic. We'll be right back. I hope your appetite is whetted. I'm rather excited because I do have the answer. To you. This is the second broadcast on Valentine's Day. This is the 14th day of February. Here comes the lab cat. She's crossing. She's going to sit down right on the keyboard. Now, honey, you have to move. Or not. Okay. Let's get a look at our lab cat here. She's right there. There she is. She's the most beautiful cat who's ever been. All right. So she's come to visit. That's very nice. What we're doing today is, in this second presentation, we're following up on our very cursory discussion of time, space, and light speed. We're trying to discover what is the correct interpretation of light as it propagates through the universe. How does it behave? Well, we do have a lot of information on that, but it's most important now to piece this all together because a lot depends on our interpretation of light. Certainly when it comes to interpreting the redshift, which is the basis of the entire cosmological system currently reigning, just reigning at the top of physics. Well, it's hard to say whether or not space is expanding if you're not sure what light is doing, and we're going to show that now. So we have discussed briefly the nature of space-time, that it does indicate a geometry, and it would have to due to the relationship between mathematics and geometry, that mathematics is derived from geometry. It's never the other way around, except in the case of space-time. That is an inversion on the usual order in science, which is that we begin with geometry and we deduce mathematical relationships from that. That is not what Albert Einstein did. Albert Einstein took mathematics and created a geometry. This is a most interesting geometry in every sense. Certainly in both senses of it's interesting in that it can be simply stated, although, well, let's just state it. What is space-time? It's the unification of time and space into one geometry, so that's easy to say. At the other end of the interesting spectrum, it's extremely difficult to describe what that even means. And the only way to do so, according to how humans have to do science, is you must be able to visualize it. This has to be a match on physical space. That is, physical phenomena, on physics, on reality. This has to be a match in some way on reality that can be defined. So, we're going to briefly cover that geometry, and then we're going to talk about the units that are used to measure things in science so we can understand light speed a little better. We're going to need that in order to get at the nature of light. So the first thing we want to do is understand the space-time formulation. To come at it from the point of view of mathematics would essentially be to reduplicate the miraculous work that took place inside of Einstein's mind. We can't do that, but what we can do is reverse engineer what he did. So what did he do? He invented a brand new geometry. There's a footnote, but I'm going to leave it at that. Einstein invented this geometry. And it's not a real geometry. It's not a physical geometry. It's a mathematical geometry. Very, very difficult to project into a visual form because part of it is imaginary. And what does that mean? In this sense, what it means is it's outside of our perceptual space. So this does require a mind expansion in some sense. One way to put this would be to add a dimension to our normal way of looking at space dimensionally, which is, according to the scientific formulation, based in this case on linear geometry. We call that 3D space. Why is that so profoundly important to form the very basis of science itself? It's, to state it one way, it's that when you start with a line and then make two lines to make an orthogonal system and then add a third, that simulates depth and that completes a construction of space. In a certain sense, it's cubic. It's cubic coordinate space is what it's called, but the coordinate grid is laid over space. It doesn't mean that space has 3 dimensions. What it means is our coordinate overlay has 3 lines, which we call dimensions, because they can be construed as a coordinate system. That has enormous value. Obviously, it's the basis of science, it's the basis of all technology. All of it comes from straight line geometry composed into 3D space. And 3D was the only mathematical space which had ever been overlaid onto the universe until 1900. To give it just a round figure, but it's within a decade or two. And then Albert, capitalizing on some work done by other men such as Minkowski and Lorentz, was able to formulate for the very first time a 4D geometry for physical space that had never been done. He did it twice, once for special relativity, which is a time-space formulation, having a special frame of reference. But general relativity has a general frame of reference, and what that means is it's meant to compute a volume space for something. In Albert's case, he used this 4D, which is a 4-line system. Overlay, it's a coordinate system laid over space, which has an imaginary axis. It would have to, since the 3 spatial axes complete what we can do with lines in space. But Albert squeezed in another line, which is imaginary, and that is considered to be time in his formulation. That cannot be correct. But it is correct in a certain sense. And it's that sense that we want to understand now, so we can get at it. We can understand its failure. It is a complete failure for cosmic space. But it's not a complete failure for local space. It's an excellent calculus framework for the computation of a curved system, which would be a gravitational system. So it is a formulation of gravity that greatly improves on Newtonian gravity. And that's the statement of the usefulness of spacetime, is that it improves enormously on our ability to get a precision measurement of gravitational interaction. These would be interactions of more than one gravitational body in order to compute the relationships between objects in the solar system. And that's the furthest it can go. It can do no more. Not according to the theorists, though, who wish to extend it to cosmic space. That's the fail point. And that's going to be the goal, for us to understand how Einstein's spacetime fails to contribute to any form of cosmology. It simply cannot assist us. Very specific reason for that, and it's amply demonstrated in the current failure model, the current failed model, totally failure of the cosmological model. Absolutely incorrect, because it's using spacetime to interpret physical reality. That does not work. It can only work in a localized gravitational field. It cannot work in the universe generally. That's what we're going to show. So in order to do that, the first thing we need to do is take a quick look at the geometry. You've probably seen these diagrams. I would assume you have. Try to picture the light cone in your mind. It is a cone that is simply a cone. So what does it mean? The first thing you need to know about this cone, it's that it is a projection downward from 4D space. Because we can't see in 4D. There's no way to do that. What you can do is create analogies. This is essentially the art of projection. In this case, a specific form of projection, in order to get a 3D analog of a higher order space. So spacetime is a 4-line system that needs to be projected down into a three-line system. It's three-line coordinate space, and you have to understand where is the fourth line. There's more than one way of doing this, but the way that it's generally done, which makes most sense to us with our visual system, to interpret this model, it's a diagram in this case, of a cone. Now you know it's a double cone because it is considered to have a negative direction, which is the past. So we begin with a plane, and it actually is a 2D plane which represents the entirety of space. Now you know that's not possible because it would have to be 3D if we were going to approach the entirety of space in order to fill space. So the 2D plane, which is basically level with the eye, when you see the horizontal axis on the space-time diagrams, that horizontal axis represents a plane that you can't see because you're looking at it edgewise. So you have to imagine the rest of the plane. Once you've done that, you've added a dimension. So the way this works out, since you're considering that line to be a plane, it's simply a visual shortcut. It is actually not either one. What it is the plane, we'll just say for now, at which is a center. And this is spatial. Time goes up and down. So that would be the vertical axis is time. And that's shown off to the side because you don't want it right in the middle of the diagram. So you have a line, essentially, you have a line that represents time going up and down. And then you have a horizontal line, and that's space. And so far that's just 2D. But you can see it's actually 3D when you consider the line that is spatial to be a plane. But now it gets interesting. Now you need to have an origin. This would be, just to put it simply, 0. 0 in 4D space. That means the center of the space at a certain moment in time called 0 time. That would be your local time for you or your measuring instrument at the moment that this is set in motion. The only way to understand space-time is by putting something in motion. And that's why these diagrams and explanations that go with them so commonly, the presenter believes that because he's somewhat mastered it through practice, but he believes that he's showing his audience something that simplifies the conception of space-time. I've seen this dozens of times, where the presenter is confident that he's presenting space-time in the most easy to understand way. They never succeed, ever, because they make a fundamental miscalculation on how humans perceive things. And so they show, it's usually a Bob and Alice thing, usually the twins conundrum or twins paradox, attempting to show basically the irrationality of space-time in a rational way, so as to make it understandable, because if it's irrational, by definition it cannot be understood. And that is, I'll just say, a major challenge, is to de-irrationalize what is essentially an utterly irrational system. This geometry does not exist, but it does exist mathematically. It has no relationship to real space. It's simply mathematical, and the geometry proves it. There has to be a geometry behind any mathematical system, because numbers are derived from geometric objects called lines. That's the definition of a number. And I won't go into the proof of that again. It has been proved. So when you're using linear numbers, you are using lines. and that is always the geometry of anything that's formulated in science. It's never curved. We don't have curved numbers. We don't have circular numbers. We don't have spherical numbers. We only have linear numbers, straight lines, a highly peculiar type of line in the universe. It's a special case of a curved line, where it's simply not curved. That's straight. That's been very useful to us, but you cannot understand the universe with a linear system. It can't be done because there's no match, and that's been known since the time of the Greeks. So what we're going to do is show just how absurd is Einstein's field equation. It doesn't mean that it doesn't work. It does work, but it works mathematically. It does not work geometrically. It only works mathematically. Well, as long as you have a confined space, you can use it. It's basically a calculus equation, which in the case of an integral, which is what space-time is for gravity, it's the integral of an entire system of mass and energy. It's the integral of that. Well, in order to get at gravity that way, you have to understand how space is being used, composed, occupied by matter and energy. Those are the two things that would fill a volume space. It's either matter or energy. It's one of those two. And that's on one side of the Einstein field equation. On the other side of the equation is a tensor system, which is a means of obtaining a curvature function for volume space, in this case 4D volume space. So it's a curvature function to explain a volume of space that's filled with matter and energy. And you've heard the aphorism that space-time tells space how to curve, and the curvature tells matter how to behave. That's there's a big hole in that. Okay, we're going to get to that. I think you can tell that I am showing some animosity towards the space-time formulation. That's very two-sided. I admire this for what it's able to do for humans. It enables spaceflight because it's more accurate than Newtonian gravity. It's more accurate than Newtonian celestial mechanics. Why? Because it takes into account the time lag in volume space, which is necessary. You might ask, why? Why would time matter? Because it's moving. Everything is moving. So, and if things in the universe, when they move circularly. In terms of gravity, it's actually elliptical for reasons which Kepler understood. Newton improved on it, and Einstein improved on that. There's nothing invalid about that when you're talking about gravity. But if you're talking about actual space, in other words, it's been reinterpreted as not just applying to gravity, that it actually is defining the structure of space, the space as a structure. Well, of course, it doesn't have a 3D structure, but it is asserted or assumed that if you add this fourth line, that now you are describing the structure of space. That's ludicrous. That could not be further from the truth, because for one thing, you began with 3D space, which is certainly not the way to describe the universe. But it is mathematically, and that's the only form of mathematics we have, is linear mathematics. Everything has to be made of lines, or you don't have any geometry. We cannot compute a circle. Not exactly. And we cannot compute curvature in general, except with calculus. Well, there's the reason for calculus, and that's why this is an extraordinarily convolute calculus calculation. But what is it actually geometrically? All right. Think of the cone as just going up. You know that there's a reflection down, which is the past. You can disregard that. We can always bring it in later, but it's much better to show this cone is just going up, because that would be reality. There is no reality in the past in terms of time. It's something that's gone. Now, there's a philosophical issue there, but it's not important. You can understand what I'm saying. This is to simplify it, because we do need to simplify this. So the plane from which the cone goes up has an apex. That would be you. You are zero. And you could be a photon. You're usually not, because not everything is a photon in the universe. You could be an electron, or you could be a proton, or you could be a planet, or you could be an instrument, but you are there. You or your instrument or whatever you're talking about is at zero. To begin with, this is without having started time. You're positioning yourself in space. It's on this plane, which immediately raises a question, because a plane does not describe space. It only describes a slice of space. So here's where it gets interesting. When you position yourself at zero in space to begin, before starting time, you put yourself at zero. You are at zero time, but nothing is moving. You're not moving, and nothing else is moving. This is setting up the whole thing to start it moving. Well, you can see there's a direct relationship between time and motion, and that is a secret of the universe. That is my byline. And we're going to make that secret of the universe work for us. It's not any longer a secret now that we're talking about it, but if you don't talk about it, it's a secret. And that is going to end up hanging by the neck, this entire model, because of the misinterpretation of time. It's a misinterpretation of time that makes the Einstein field equation work in local space, because you're treating time as if it were a spatial phenomenon, which it is not. So let's see what happens when you assume that it is, that it's actually a spatial phenomenon. Here's what happens. You begin at zero by positioning yourself, we're just going to say, what should we call it? Let's start with a photon and see what happens to a photon that's frozen in time. This is our goal, so this is probably the best example of all. We'll give a couple of other examples in a moment. But for a photon, this is a very special case, isn't it? Why? Because a photon travels at the speed of light, correct? That's the definition of a photon. It is that which, when it's in motion, travels at the speed of light. Now, can we say anything else about its motion? Is it linear? No. A photon does not travel in a linear fashion, although it could. But if you just have a photon that has no history, it's just there, and you begin with a photon, this is highly artificial. Because actually, there is a linear component to light propagation. This is the very heart of the quantum paradox in terms of the interpretation of the photon. Because the photon is by definition a particle. But that particle never actually exists except by deduction. And in fact, it can be pinpointed with a measurement, but the only time that light is ever a particle is when it's measured. At all other times, it's a wave, which is the opposite of, it's not a particle, and they don't overlap. It can't be both. It's either a particle because it has an actual location, not just a locality. It has a position. That's the definition of a particle, is something that can have position. When you're treating it atomistically, that is, what would be something that has a position? It would be a particle. It could be as big as a sun, but you're treating the sun as having a center. And that would be equivalent to a particle, although then we call it a point because it's geometric. This may sound abstruse. Don't let it confuse you. It's very difficult to get at, but I think I have the right angle to show this to you. Because the light cone, as you know, is worshipped. It's worshipped just as much as the golden calf is worshipped. And we need to melt it down because we don't want idols. That's what's misleading physics, is having an idol. It's called a model. So here's the diagrammatic portrait of the model, which is Einsteinian geometry. This has a technical name, but I won't give it to you because it's daunting. I mean, just from the name of this geometry, you would realize there's something wrong. But I won't say it right now, although I have in prior lectures, what this geometry is actually called. It is a geometry, but it's not a geometry that exists, except mathematically. It's a forced geometry. It's actually an involute geometry. It's inside out. It's actually inside out from real space in order to deal with time. So here we have a position, and we're calling it a photon, and now start time and see what the photon does. If it's just a photon in free space, having no history, it's just there, highly artificial, but we know this is the behavior of light in the sense of the way it propagates in space. If it's just a photon and you start time, it goes out at the speed of light as a sphere. That's the definition of a a photon in free space. One photon in free space. Not a collection of photons, which is something a little bit different. And we're getting at that because we're trying to understand the propagation of light, not photons. But you see, light is conceived to be photons, isn't it? It's one of the standard model particles, is a photon. It is a particle in the current model. So you could say that, but you can see it's hazardous to say that, because a photon does not travel as a particle. That can be argued. So this is a highly artificial, but a highly instructive way to look at the light cone, which again is worshipped, okay, because it's considered to be the bridge to 4D space. So if it's a photon at the origin of space, this is arbitrary, so it's our origin, that's the special frame of reference, is at 0 space and 0 time. That means it has 3 coordinates that are all 0 and a time coordinate which is 0. So now we want to study how the 4 numbers change when you start time. When you start time, you have to have a metric for that axis. You have to know how fast time is traveling. Well, that'd be light speed. So what does that mean? How do we index the vertical axis? Because now the photon, if it's just considered in terms of its time and not space, it goes straight up at the speed of light, which is a 2D number. It's the amount of time covered, I said that backwards, it's the amount of space covered in a certain amount of time, which is a fraction, called a proportion. It's the proportion of space to time, and that's called velocity. But if you're only talking about time and not any kind of direction, just direction in time, it would go straight up on a line. And so the photon would go straight up. But the light cone is what describes its spatial trajectory, which has to be spherical. It actually, in space, goes out spherically. So it's really a sphere that's going out as time proceeds up. So think of it as a sphere that's expanding and going up. So the sphere is expanding in space, but in space-time, the sphere is not only going out in space, it's going up in time. That's forward time. So it's a moving sphere. Now, the way that's shown in the diagram, that is the projection, it's a 3D projection. There's one dimension you cannot see, and you can choose. You have to choose which one you don't want to see, because you can't see them all. Well, we want time in there, so that's the vertical axis. Well, that means that we have to contract one of the three spatial dimensions, because we've used up one of the spatial directions. Up would normally be part of one of the axes for space, but now it's been taken by time. So we're using one of the space, normally would be the space axis, one of the three, this one going up and down. But it's being used for time. So we're visualizing a three-dimensional space particle traveling up in time. So it's a sphere. In the case of a photon, it would be an expanding sphere. And then you can see the sphere. If there were no time, it just goes out from its center point. But if you include time, which of course, that's the whole point, is to include time, which makes this so laughable. I mean, it's funny in a way. The sphere, okay, is expanding. Well, it's also going up. Well, that causes several things to happen to the geometry which are desirable if you're trying to get at gravity. Because the whole idea behind Einsteinian gravity is to compute the time lag in the volume space. Well, this would give you the framework for doing so, but it certainly is odd. So now we have a photon that's expanding spherically, but traveling up in time. Now, if you want to diagram that, which so far we haven't, I've just told you it's a sphere which is going up. Well, you can't diagram that. So you have to have a convention for showing it. That's called the light cone. So the cone, if you look down if you have a cone and you get above it and look down so that the apex is like right in front of you and the rest of it is going down, it's a bullseye. It's a circle with a center, right? Okay, that should be helpful. I hope that helps you, because it gets spooky at this point. So, the cone actually represents a series of circles, right? If you look down from the top of the cone, what's happening is you're seeing an expanding circle. That would be the motion through time, by the way. So the motion through time is basically an expanding circle. But is it a circle? No, it's a sphere. And that's the extra dimension that you lack in the projection. So you've used up one of the axes for space in order to show time, and therefore you have to put 3D space into 2D. Well, that's that circle that goes up on the cone. That's actually a sphere. And from that seemingly very simple, I hope I made that simple enough. It is true. That is what is being shown. But my word, what kind of geometry is that? At its base, its class name among the geometries, and you might ask, well, how many classes of geometry are there? There are 3, and one of them is linear geometry, but there are 2 others. And one of them is elliptical geometry, which is essentially the geometry of the sphere. It's called elliptical geometry, but of course it has to be linearized to be understood at all in mathematics. So it's called elliptical, but the ellipsoids include the sphere. Okay, so that's what elliptical means. The same thing is done in the nomenclature for galaxies. There are spiral galaxies, but there's one other kind, which is normally or conventionally called elliptical galaxies. But they're spherical. Essentially, you can always abbreviate it spherical. I prefer to do so because I've developed the actual spherical geometry. That's my discovery. I discovered spherical geometry. So elliptical geometry is different from spherical geometry, but it's the linear version of spherical geometry. And then there's only one other. It's the other family of curves. The ellipses form a family of curves because ellipses are stretched circles and ellipsoids are stretched spheres. They take all kinds of shapes when you stretch them, but they're essentially spherical. But there's another family of curves that are not closed. They're open curves. And that's the family of hyperbole. This is well known, but if you don't know it, you could study it to great advantage. This is very, very, very interesting, fascinating, and enlightening study. Geometry will never let you down. You can't go wrong in studying geometry. You can definitely go wrong in studying mathematics. Sorry, my phone is acting up. So the family of hyperbole is one of 2 families of curves. That's very simplified, but it's known. And then in between the 2 are the straight lines, which are highly peculiar. They're actually in some way in between the family of hyperbole and the family of ellipses. Now, the hyperbole are by far the most difficult to study because there's no clear physical analog for hyperbolicity, although it can be discovered. There is such a thing as physical hyperbolicity, but not in the case of gravity. Gravity is spherical, so it would be subject normally to elliptical geometry, but elliptical geometry simply cannot address it because it's based in linear geometry. What you want is a base system that's elliptical, essentially elliptical numbers. Those have never been discovered. Although we're getting to my discovery, which is precisely that. Now, in the case of the hyperbole, these are open lines. That is, they're open curves. They don't close. And there are different, I think it's called acuteness, but there's some word that describes whether it's obtuse, a very long, not too high hyperbola. Well, if you're going off into infinity, it just keeps going up, but it goes up to maybe, well, I just say a limit. But then as you see, this would be a hyperbola, it can then close up. Well, once it reaches, if you keep going, what's going to happen? Well, it'll seemingly close to a line. That's essentially true. It will close to a vertical line. It began as a horizontal line, and a curve is changing that line to be more vertical. That's called curvature. But it's not a linear concept. Curvature is not a linear concept. It's in between horizontal and vertical. As the line begins to bend, it begins to curve, But if it keeps going, it reaches a limit and then closes, correct? Of course, you're going up, and if you keep going up, it's going to close. Well, it's quite mind-bending, but it is very well studied and understood in that sense, although not really understood in another sense, because we simply cannot compute curvature except with calculus. Otherwise, we're not seeing physical reality directly. So to make this long story a little bit shorter, what Einstein composed is in hyperbolic geometry. It's a hyperbolic space, and the computations that are done for the Lorentz transformation and physical length foreshortening and time dilation all have to do with this hyperbolicity in the space, which is asymptotic to the speed of light. That cone represents 1. Its speed of light normalized to 1, and everything inside, in terms of space-time coordinates, is computed with hyperbolic algebra, which instead of using, for instance, sine and cosine, uses sinh and cosh. And I understand that is how they're pronounced, sinh and cosh. I never would have pronounced them that way, but they do have pronunciations. And it's the hyperbolic sine and the hyperbolic cosine. You also essentially need hyperbolic calculus, which produces an extraordinarily complicated, extraordinarily huge equation, all of which must be computed in order to get you a result in hyperbolic algebra. And there's your geometry, except it would be wrong to stop there and say this is hyperbolic geometry. Because if it were hyperbolic geometry, it would have its own number system to compute the curvature. But it doesn't have its own number system to compute curvature. It has linear numbers to compute curvature. And that's why you need sinh and cosh, is to compute curvature with linear numbers. And so this is not hyperbolic space. Although it's called that, it's wrong to call it that. It has a very specific and accurate definition in geometry, of which I am something of a self-made expert, I guess you'd have to say. But this can be proved. It's just usually not brought out this way because, well, for one thing, it's kind of embarrassing to admit that we don't have a hyperbolic geometry. And we certainly don't have a spherical geometry, although I do. And it would have to have its own number system to be a geometry. It does. It's not linear. And that's a major breakthrough in physics. So this light cone represents the expanding sphere of the photon, which you might think is just right next to you, just a light source and you, and then you go in a trajectory, of course through time, because now time has started. You never stop moving once time starts. And again, that shows a critical relationship between time and motion. Space knows nothing of that. Space is static. There's no motion in space, and that's actually a definition. Space is that which does not move. And the concept of a particle is a point of matter that does not move. Or if it does, it takes its location with it. But a photon does not do that, so it's not a particle. Only a proton can be called a particle in space. The electron, as I've shown a couple of lectures back and several times over the past year or so, that the electron is not a spatial particle. You could say it's the time particle. But here's where it gets interesting in our use of the word time. Time is not exactly real. Space is, because positions can be created in space by matter, and therefore space has to be real to the exact proportion that particles can be real. And since there is such a thing as a proton, which makes an exact position in space, then we have a complete definition of space as the, you could say, medium in which a proton exists is space. And space is the medium in which the proton is. They define each other. The proton defines space, and space defines the particle, which would be the proton. That leaves out the electron. Why? Because it's not a position in space. It has a locality, but it's not a position in space. It's a fuzz. And that's a highly unscientific term to call it a fuzz. What is it? Actually, we know. Physics knows what that thing is. That is the electron. It's a wave. It's a wave that has locality. And in that sense, you could say it's a particle. And you can say it's a particle. It is a particle. What is it not? It's not a space particle. It's in a different dimension. We would say perhaps the dimension of time. You have to if you're trying to reverse engineer the Einstein field equation. But what you're actually trying to reverse engineer is not time. You're trying to reverse engineer intrinsic motion, original motion. Angular momentum at the cosmic level is the electron. It's embodied in the electron to the same proportion that the proton embodies a location in space. Each has an aspect of the other, exactly like the yin-yang relationship, where you've seen the yin-yang symbol, where the circle is divided into two equal halves on two touching circles, which then you erase part of the circle above and you erase part of the circle below, and it makes two fish that are chasing each other. But the key to the whole thing is, if you consider one a white fish and the other a black fish, the black fish has a white eye at the center, and the white fish has a black eye. So there you go. That's the yin-yang. I believe it may be called, it has another name, but you know what it is. I call it the yin-yang symbol. That is the exact nature of the relationship between the electron and the proton. That the proton is a space particle that has an electronic core, and the electron is a motion particle. It's an angular momentum particle that has a protonic core. That will have to do for now, since the cat is rousing herself, and so I must tend to my small family here. I hope that helps. We haven't gone too far into it, but we're getting there, aren't we? So pseudo-hyperbolic geometry is the basis of space-time. It does not actually exist, and so it must be reformulated, or we'll never understand the universe. Well, I've done so. So that can be solved. What we're getting at, then, is the nature of the photon. And it's the photon that is just really the most magnificent phenomenon of all. Is, first of all, that we also think of the photon as being a particle. And in the same way that we think of the electron as being a particle. Well, the electron, obviously, as you should accept by now, can only be called a particle if you distinguish between two types of particle, where you could say that the proton is a space particle, and that's the only way to say it, unless you want to say mass, but that's actually the definition of a proton is it is mass. That is what mass is as a proton. Well, what's the electron then? It's motion. It's a quantum of motion. It's not a quantum of space. That's the whole point. It's not a quantum of space, but it's in space. Now, conversely, and this is critical, we're getting to this, The proton is a position in space. But then you have to ask why. Really what you're asking is how? How is the proton manifesting itself? It's by centrifugal force. The electron manifests itself, it being pure angular momentum, but it manifests itself in space by centripetal force. The proton manifests itself in time, or you could say in the potentiality of motion, in a domain that would give rise to the potential for motion. That would be called space. But you see then that space can be defined in terms of time. But that's not the right way to say it. It could be said that way, and Einstein did say it that way, but there's a better way to say it. You're defining space in terms of a motion dimension. That's something that will support motion, but is not itself motion. The electron manifests itself in space as a localized phenomenon, but it does not actually have any position. It has a relative position in space, just as the proton has a relative position in time, except in the case of the proton, well, you could say it's absolute in space, but if it's space-time, it's a relative position in space. That is, it's a relative position in time. It's an absolute position in space. But if there's motion, which is equivalent to time here, then you have the potential for the proton to move. Well, what about the electron? It is motion. It's already motion. But it has a relative position in space, which is actually impossible to localize to a position because it's a wave. The proton is not a wave. But the electron, to be held together, has to have a centrality function. That's called centripetal force. And for the proton to have an existence at all, it has to have a centrifugality nature. But the nature of the electron, since it's angular momentum, that motion is synonymous with centrifugal force. So what holds it together? Centripetal force. The proton has a definite position. It has a spatial manifestation that is exact, which the electron lacks. But in order for it to maintain that nature, it has to have centrifugal force. So the proton is the manifestation of centripetal force. We call that, well, that actually is gravity. It's a quantum of gravity. The proton is a quantum of gravity, which is spatial. It's nothing to do with motion. But in order for that force field to exist, which has an effect on the electron, to draw it in until it reaches the centrifugal shell. That is the nature of the proton, is that it establishes itself as a center in space by the use of centrifugal force, beyond the shell of which is centripetal force. The electron is the inverse of that. Its very nature is centrifugal force, which normally would disperse because centrifugal goes out. But it doesn't go out. And why not? Because it has an intrinsic centripetal nature, to the same proportion that the proton has an intrinsic centrifugal nature. They each establish themselves in space-time, which you can think of as space/motion, one being static, the other being motion. It's very interesting that these two concepts It's the most interesting relationship, I think, of all, is the relationship between space and motion. And when you talk about motion, you cannot talk about motion except in terms of time. You can talk about space without ever mentioning time. Well, Albert said, I can invert that so that you can no longer talk about space without talking about time. And he got a construction that's a very close match on reality. But it's still incorrect. I have the correct geometry that explains all of that and much more. So that's an hour. We'll be back. This is Valentine's Day. I hope you have a Valentine. I do. She's in heaven right now. She's passed into the further realm, which none of us will ever know about until we get there, will we? Well, unless you have some religion that informs you, but hey, good luck. I hope you have a Valentine and a very happy Valentine's Day. We'll be right back. Don't forget to keep looking up. That's where you're going to get the direct answers. This is just mathematics. This is just geometry. This is just fun. You have to actually look so that you can unify yourself with reality. It can be done, but don't ask around. You do it. You be the first. You won't be the first, and you won't be the last, but you'll be one of those who does it. You have to do it. No one can do it for you. Welcome back. This is Anagalactic bringing you the third in a three-part series on Valentine's Day 2024. This is the most difficult problem that has ever faced science. By far the most difficult. It's been 70 to 100 years since either aspect of the quandaries we've encountered in the universe have been known of, but no mind has been able to penetrate it yet. But it's inevitable in the progress of science that finally the nut must be cracked. So in this third presentation on this day, we are now going to get into the actual solution. The top brains on Earth, including Einstein and everybody else, have been unable to penetrate this problem. What is really interesting to begin with is to try to put into understandable words, what is the problem? I am a scientist, but only in the largest, most embracing sense that we're all scientists. If we're trying to study the universe rationally, we're scientists. That's the right word for it, but there are professional scientists. Well, indeed, there are professional mathematicians. There are physicists who make their livelihood at physics. So I'm none of the above. And so I represent you. I represent you and me. I represent all of us in the lowest common denominator sense, which is not very flattering at the outset. It's just, I'm just a common Joe. But I have an angle on the common Joe perspective that every common Joe definitely needs to know about. And so in that sense, I'm the man. Each of us has a specific contribution that we might be able to make given our aptitudes, our environment, and the amount of time we have. Just a lot of factors. But I'm of the firm belief, as indeed was Fritz Vicky, my teacher, that each human being is a genius. Comes the lab cat. And by that, what I would say that means is, because genius is kind of what are we talking about here? Your ability to make a contribution that everybody can appreciate and learn from and grow by and be very happy with, but only you were able to formulate it. I am firmly convinced that every single human being has that. And then I'm just going to leave it at that. So none of us is left out. And in fact, what we should be looking for is the way we're all included. I mean, the Big Bang model really doesn't pertain to people. It's a cosmological model for people who are vying for university positions and contracts, funding, and they're competing. You and I aren't. We're just watching to see how the whole thing turns out. But what are they fighting over? Well, in science, what we want is not what anybody's fighting over. We know that that's the incorrect approach to take. And so men like Dr. Brian Keating just make us sick to our stomachs because he shows that he's not on the side of humanity. And the same thing can be said of Bernardo Castro. Now, we just as people, not in the industry, our livelihoods don't depend on kissing the ass of some idol or, bowing down to some model and swearing allegiance to it. We don't have to do that. We shouldn't do it. In fact, technically, no scientist should do it. But things develop in this world to promote these hideous situations where emotions get involved because there's money. And money! Not for us. What we want is way more valuable than money. And I am dead serious. We want the truth that we can take with us forever. Whatever life and death imply. While we're here, while we're conscious, while we're still kicking, we have our noodles are working in some way, we have committed ourselves voluntarily, consciously, exclusively to non-emotional results. Pathetic gods that die and are buried and are turned back into mud. Well, that's pretty weird, but that's what we were born into, and you got to make a decision. You can either be a sucker, but if you're logical, you'll realize that you have two sides, and one of them entails a commission. One of them entails a commitment. It's when you grow up, you become a big boy. Most men don't. So why do science? It's because your design blueprint tells you to do it. So now you have to start asking questions. This is where we wake up. This is when a man is born. It's not at the age of 13. Bar mitzvah does nothing. And your baptism into your church is shit. Doesn't mean a goddamn thing. In terms of you waking up and facing your creator. You have to face your designer. You have to deal with your design blueprint because it's not yours. You were born with it. And all this stuff about people hating God and saying they're atheists. Oh, I'm an atheist. They're like, that's a badge. It means you're an idiot. It also means you're not a scientist. So the ranting out of the way, here's what we're doing in exploring cosmological redshift, space-time, quantum mechanics, and the whole nature of reality. We're doing it because it's what we're told to do, but it's voluntary. You cannot force love. That's a maxim known all over the world from the beginning of time until now. Love is not love if it's forced. Well, the same thing is true of rational logic. You cannot force someone to be logical. They will defy you if they feel like it, and there's nothing you can do about it. You can say, hey, we just found out the Earth is not the center of the solar system, the sun is, and prove it logically. They used to be your mates, they used to be your family, but now they report you to the Inquisition, you're taken away in chains. Well, that's going on today. It's just they can't do to us what they'd like. Us would be those who are trying to overthrow the goddamn model. Well, we as scientists, we try to get the truth. We want to know what the universe wants. We want to know why we're here. You have to be logical. Okay, well then you open up the science books. What does science know? What is logical? What can be proved? Well, the cosmological model cannot be proved. But the ones who support it say that it's already been proved. You just look at Neil deGrasse Tyson, That man is absolutely a shambles. Brian Keating, Dr. Brian Keating is the latest man to step up and just break down in front of us in tears and agony because he wants to kill Eric Lerner. Just eliminate Eric Lerner from his radar. He can't, because Eric Lerner has destroyed the Big Bang Theory with the evidence from the James Webb Telescope. The game's over. Now what I'm doing is following up on the work of all my predecessors. This would be Zwicky, Arp, the Burbages, and all the way to the present day, Eric Lerner. Dr. Eric Lerner certainly can't be refuted. Well, what I don't want is to be involved in a war where I have to come out with a sling and nail the fucker in between the eyes to kill him. That can't be done. The cosmological model that exists now could be disproved a billion times. It could be disproved by the Pope. It could be disproved by every president on Earth. It could be disproved on live TV. These bastards will never say no. They will never give up on their model because they're self-centered little brats. And if they're defending their family, God bless them. Dr. Brian Keating, I just feel sad for you. I am just sad for you because you could be on the side of the truth with me. You never will because of what you are. And the same thing is true of Neil deGrasse Tyson, the military drill sergeant of physics, just to get rid of God, get rid of supernatural, get rid of the proof that we have of where we're from. No. He's on the same side as Dawkins. He's on the same side as Larry Krauss. He's on the same side as the pansies, such as Brian Greene and Sean Carroll, and the sycophant, lickspittle interviewers like Lex Friedman and Kurt-Jai Mungle. They're all in part of an industrial fantasy land. But the real men who've grown up, and there's always some of us, it's not just Eric Lerner. I'm with Eric. I'm with the heroes. And I intend to act like it, although maybe for the past 5 minutes I didn't, because I'm emotionally involved. And I'm running out of time, because I'm old. Older than I was. 70 years old, minus a few months. So I do need to get this message out for the sake of science, not for gain. I will never get a penny from this. So why do I do it? Why do I waste my time? This is my commitment, because I'm a full-grown man who's heading for the next whatever is after this. On the other side of, the Great Divide. Once you go through that veil, nobody can follow, and you're not coming back. I want to be ready for that. This is how I'm blueprinted to get ready, to understand the universe to the best of my ability. Well, I've also taken a vow to science. Although I don't have to follow it, I'm perfectly free to just flip everybody off and say, I got mine, mate. So I'm trying to share this. So what is it I'm trying to share? Well, we would like to have a reasonable point of view on the universe. That's really the bottom line. I mean, what do we know about the universe? What can we say about it that we can share with others? How can we share what we know about the universe? Well, first of all, you better find it beautiful. You better find it overpoweringly awesome and something you never, ever want to get away from because it's so beautiful. What you don't want to do is start denying God and just saying that you're the king of all shit, and you're going to talk to the children and tell them they have no hope and smile at them at the same time. You don't want to do that. That's what Larry Krauss does. That's what Neil deGrasse Tyson does. And that's what Dr. Brian Keating does. They're anti-life, they're anti-logical, they're anti-rational, they're anti-human. They're idiots. And that's the dividing line. It's very simple to come out of that nonsense. You become honest. You don't defend a model just because it puts butter on your bread. You don't defend the model. People have made their living under Hitler. People make their living in the United States under these various presidents. It doesn't mean you're liable for their sins, but you do have to make a living. Well, serve the goddamn industry. Do whatever you have to do. But keep your soul pure for your creator, for your design blueprint. You don't have to go to church. You have to read the Bible. You don't have to light incense. You don't even have to tell anybody. But you do have to have the right orientation, the right attitude. That you didn't invent anything. And none of these men that came before you know anything more than you do. They're just like you and me. But boy, do men love to posture. Is that what I'm doing? Yes, but to introduce a very good cause. So what is it? What is it that I want to present? Well, we were covering space-time, and we got the geometry of space-time, which is pseudo-hyperbolic geometry, which is not real, and it uses a linear formulation, a four-line system, so that doesn't work. And we've given all the footnotes, so none of what I'm saying is out of context. Space-time needs to be reinterpreted to get it right, because it's wrong. We need a different cosmology, or simply get rid of the cosmology we have because it's incorrect. And we need to understand quantum mechanics. That's where I always like to jump off from. Because why do we want to understand quantum mechanics? It's so we can understand light propagation. And light is a quantum phenomenon. How can I say that? It's known, but let's reiterate. Why is light propagation a quantum phenomenon? I can sum it up in one word: photon. Is light photonic? No. But does it behave like a particle at any time? Yes. That's called the quantum paradox. And it affects the electron. In fact, all of the quantum paradoxes that so far have been proposed, almost all of them concern the electron. A few concern the photon because the photon is derived from the electron. It's an electronic phenomenon, not traceable to the proton. Although it has been pointed out to me in the past, and I've been meaning to come back to this because it's a very important footnote, is that gamma rays can be induced in the proton. That is, the proton has the capacity to produce light. And I have the answer for that. But in order for me to give you that answer, I have to give you the full geometry, the full mathematical construction, and how it compares with what is thought to be true, so that you get a better perspective on what actually is true. Because don't forget, we're always taking an angle on things. We're not gods, and we never will be. And we're always going to be wrong. We're always going to be beginning, and we're not really going to understand anything fully. It's impossible in these bodies. It certainly is impossible in the amount of time that humanity has. We'll never understand the origin of the universe. That's so far beyond reach. That's like, we can't even fly to the stars. We'll never get to another star. If you can't even get to another star, how in the world can you pretend to know the origin of the universe? You can't even move. You don't even know what you're looking at. The universe, you can't even see it. I mean the edge. You can't see the edge. Well, we're going to get into that so we can straighten all that out to get rid of medieval Dark Age superstition. Which, sorry kids, maybe you have jets and cars and cell phones and computers. That doesn't mean that linear algebra works in the universe. It does not work in the universe. So where are we going with this? The quantum paradox is at the basis of light propagation. And why do we need to understand the propagation of light other than the obvious? Wouldn't that be nice to understand? We need to understand it to answer a long-standing dilemma. about a century old, about redshift. Redshift has to do with light. It has to do with the structure of light. It has to do with a record of light called a spectrogram. When we get a reading on a distant galaxy from the James Webb Telescope, we get two readings. One is the photograph, and the other one is the spectrogram. And if you don't know what both of those are, you've got to find out. Both. What do we learn from the photographs? From the James Webb Telescope, that's simply the latest, but emblematically from that telescope. Yes. What do we learn from those photographs? Well, there's an answer for that. And then what do we learn from the spectrogram? First of all, we get the redshift, correct? Yeah. There's a correlation between the photograph of that galaxy, which has certain aspects that can be measured and studied, and there's a relationship between that aspect, which includes a feature called surface brightness, which is specific to an extended object such as a galaxy, doesn't pertain to a star, pertains to a galaxy. An extended object has a surface brightness. If it's a star, it's not called surface brightness, it's called luminosity. And so luminosity is the stellar version of the galactic measurement called surface brightness. And that essentially is the overall luminosity of the object. We can also see features. We can see if it's a spiral. We can see its orientation in space, which is rather random. But we can see the nature of its core, whether it's a bar spiral or a regular spiral, or if it's not a spiral at all. 55% of the galaxies in the universe are spherical. Usually called elliptical, they should be called that or spherical. But the spirals are spirals, aren't they? How do they form? One of the major unanswered questions. I know the answer, but science does not, physics does not, astrophysics does not know, but I do. You would think they would have caught up with me by now, since I'm way behind them in studies. And yet I got it and they didn't. So that's one aspect. I know the morphology of galaxies and much more than that, and can explain the supermassive black hole in a way that they cannot understand. Because it's right, it's true, it's real. It makes sense. It matches the data, and it gives us a lot more understanding about what that phenomenon is. But you'll never get it if you're serving your model. Because the model will tell you what it means. And then you'll get it wrong. Every time. Every time you'll get it wrong. The only way to get it right is to get it. You have to get it. They're not going to help you. The astrophysicists won't help you. The mathematicians won't help you. They're busy. They're busy putting beans and meat on their plate, okay? And driving nice cars. Serving the government. You and I don't have to do that. We can serve a higher power. It goes, oh yeah, this is deep. This is where all those threads come together. When you become a real man, you turn on your logical mind and you start taking accountability. You start taking responsibility and you start working, perhaps for the first time in your life, as if your life depended on it in some cases, to get rational answers. Like, where are we from? Where am I from? What's our origin? Well, you're not going to find out if you listen to the experts. They will not only not tell you, they'll make sure, and they'll check to make sure that you get it. You're from monkeys. There's no designer. Oh, stay away from that stuff. Well, then you're telling them to stay away from science. There would be no such thing as science if there were not a design. That is what we're studying. Something that was designed. Oh, but that suggests a consciousness. Tough titty, said the kitty. Okay? And your milk's gonna run dry one way or the other. That's in honor of my Valentine Day sweetheart, whose tale you just saw go by, I think. So to wrap this up, to complete our trilogy, we're talking about the propagation of light in free space. We need to understand the mechanics of it in order to explain redshift. Because currently, it's not getting into the emotional side any longer. I just tell you, the redshift has already been interpreted for all of us. The cosmologists know what redshift is. It means absolute recessional velocity, which means that the universe is expanding, even though that makes no sense and is anti-physical in at least two ways. They say so, and that's the end of the matter. That's what redshift means. It means absolute recessional velocity. I'm going to tell you what it really means, not according to these pros. What it meant to Hubble, he reported, and he said it right. The redshift of galaxies, which is a relationship with distance, so when I say the redshift of galaxies, I'm referring to this sequence of measurements proving the relationship. The simplest relationship of all is a direct correspondence. That's called a linear relationship. So there's nothing difficult about redshift. What you want to do, though, is figure out why there's a redshift. And that's what's already been determined and is a bald lie. It means absolute recessional velocity. Well, that's basically the plum pudding. That's basically the plum pudding which is overthrown by the Bohr atom, which has a structure, whereas the plum pudding was just a bunch of electrons in a pudding. Well, that's what the universe is now, according to the latest round of jackasses. It's just a plum pudding, except it's expanding. So the little plums or raisins or whatever you might think, pieces of rat shit, are expanding because the whole loaf is expanding. And then if you check with a cosmologist to see if you can get a better explanation, because that makes no sense. It's absolutely anti-scientific statement that everything is flying away from everything else because you say the redshift proves it. Well, you're out of your mind. So you try to find out why they say this, and they can't agree with each other. They don't know why they say it. And then Einstein is brought in as if Einstein were to blame for this. The reason is you can use an extrapolation of Einstein's equation for gravity. If you extrapolate it with something called a metric, like the Lemaitre-Walker metric or Robertson-Walker metric, or any one of about 6 to 12 to a million metrics to interpret this shit, which is already wrong, they can extrapolate a beginning to the universe, and then they argue over how fast it's expanding or if it's accelerating. Neither of which applies because it's totally anti-physical. You can't have expanding space that just expands without having anything to expand into. And you can't have an origin to that. There cannot possibly be such a thing as a Big Bang because it won't fit. And you have no origin. It's a singularity is what they say. Do you know how insane that is to say that? It goes beyond being anti-physical. It's just psychotic. It's off the wall. But they have Einstein, they say, to prove that the redshift proves Einstein, and that Einstein proves Hubble, and Hubble said the universe is expanding, which he never said. And you know Einstein was very, very unhappy, and he switched his mind at least twice on whether this stupid-ass model had any cogency at all. And once it was shown to his face that your own fucking equation predicts it, which is a lie, they fooled Einstein. So this is a massive, massive deception. I swore, the whole reason I made 3 videos was to get that, it may have something to do with the Valentine's Day celebrational water, which again, this is where I live, not the Sierra Nevada. but Old Chico. Which is quite a ways from the Sierra Nevada, but whatever. So that's why we want to understand the propagation of light, which means we need to understand the quantum paradox and completely figure it out. But we're not going to do so while we're under the jurisdiction of space-time, because space-time is ridiculous. So space-time is wrong. Quantum mechanics has never been understood, and the whole cosmological model is wrong. I don't know how bad it could be. Worse than that. I don't know anything. Well, it's worse than that. We got everything wrong. Who's we, white man? As my mother used to say. You know, it's not we, it's they. It's our ancestors, our predecessors. Well, they are under all kinds of ecological and environmental pressures. You know, their government. They got to make money. They need to rise in the ranks of professorship. So you better go along with the crowd. You better lick some butt. And we can forgive them. Not as scientists, we can't. As scientists, they deserve the worst. But they can be forgiven as humans, and that's why I shouldn't be screaming. Because now I'm just like them. I mean, it's terrible, it's terrifying, but I am involved. I am just as human as they are. I'm just not as devilishly deceived. That remains to be proved as well. Oh, everything has to be proved in science. You're not allowed to say things that are not true. Well, you can if you want, but you're still not allowed to. But then who's going to call you to account? Nobody, if the government is giving you money to lie. If the money that you get comes from a government that requires you to lie or pretend or mislead, do it. I can't, because I'm a real man. I am enlisted to a higher power, nothing I can do about that. But you can defy God if you want to. Just deny him. Just say he doesn't exist. All the professors do. Yeah, and then you're rolling the dice on your soul. I will not do that. I want my soul to be in good, protective hands. Not with these bastards! So I do take a hard line against liars. I just can't stand liars. It's one thing, and we all lie to one degree or another, but let's be honest about what is a lie. How much destruction is it causing? You might lie to protect yourself. That's always forgivable. Of course it is. You have to lie to protect yourself sometimes. But would you lie to hurt someone else? Well, then you need to be punished. If you lie in order to cause harm to someone else, or it causes harm to someone else because you did lie, whether you intended it or not, you're liable. In the cosmic courts, where I've obviously been and served as a stenographer. No, this is just telling you where I'm coming from. This is why I do this. Why I'm so serious. I want you to take this seriously, but if I don't get around to it, there's not anything you can take seriously. He never got around to it. He never told us. He ranted, he raised his voice, we leaned in, and then he never told us. So this redshift needs to be understood. Well, that's a phenomenon of light. Why is it redshifted? Nobody knows. Nobody knows what causes the redshift of light. One thing we can say that's indisputable, that everyone knows, it's caused by distance. But is that really the cause? No. That's the instrumental cause. Is you can say the reason there's redshift depends on its distance. As it's more distant, there's more redshift. That's been proved. Nobody will ever unprove that. But then you have to ask the question, which of course has been asked. Why is the light shifted red? And we discussed what that meant. it's essentially an overall decrease in energy because the band of the energy has been moved down towards the less energetic range. That it used to be this band of light was like, well, if you look at a part of it, you're really looking at all of it. You just have to extrapolate to what the invisible sides. But when we use optical astronomy to take the redshift, you're getting the range of optical light, which then shows the overall shift of the entire packet. It's really, well, it's the light that we gather from that object. Will have that component that you can read when you unroll the spectrogram of the light. It will tell you. It's a number. It's very simple, but my God, is it profound in its implications. Yes, you could expect that light would lose energy with distance, but in science you still have to say why. It didn't just lose it by magic because the fairy godmother waves her wand over all the light passing through the universe, but you do have to fill in the blank. There's something there that's changing the light characteristic. What makes it interesting is it's not just the band of light which is weakened. That would actually be difficult to detect. But it's the fact that it has lines called absorption and emission lines. These are called the light and dark lines of the spectrogram. It's due to its source. That the source of the light was an atom somewhere, and compositely this would represent the collection of atoms either in a star or a galaxy which is composed of stars, and when that light reaches us on Earth, we can unroll it, and there are the lines. It shows us the chemical composition of the atmosphere of the stars, and it's never wrong. And we know this so well that I would have to say this is one of the most miraculous things that's ever been discovered. It's equivalent to the discovery of DNA, which disproves natural selection, which is a major hurdle in the life of a real man, is to somehow get rid of that superstition that we're descended from the ecology, a total fabrication of psychotic men, including Charles Darwin, who at least had the balls to admit that he was wrong. He knew that he was wrong. He said so. But he was still trying to make a living, so he was hedging his bet. He was trying to sell that book, and he was trying to more or less sell his ideas so he'd be taken seriously because his father was famous, and he felt compelled as a scientist, I deserve fame too. Well, more power to you, Charles. I think he did a good job. He's a good scientist. He certainly came up with an interesting theory, didn't he? No, he didn't. What he did was he honed an already known theory that was invented essentially by idiots because everyone wants to get to the top. Back then they wanted to be known for some discovery, geology, biology, because you make a better living, Charlie. The governments want your results if it can benefit the government, and if you're just doing religion, the government doesn't give a fuck about you. But if you're doing electrodynamics or something to do with, well, it's more complicated than that. But what I'm saying is, you have a theory which is accepted for a long time, which never had a wheel to stand on. It's very difficult to rationalize to a youth. And I consider myself to be a youth. We're all beginners, and you should cultivate that humility. We're always going to be beginners. But guys like Brian Keating don't sound like beginners, do they? They sound like King Tut, right? They're very self-important bastards. That's what Fritz Zwicky called them too. Members of the Big Bang Cartel, they're bastards. They're anti-science, they're anti-rational, they're anti-human. So what am I? I'm the good guy. And it's not easy. So what is redshift? Well, you want the straight answer? Nobody knows. Nobody knew until I figured it out. And you can see that I'm very sensitive about getting the Raz. Well, when I see that a real scientist such as Dr. Eric Lerner points out the Tolman relationship has been violated, and therefore the James Webb Telescope data falsifies the Big Bang model, and then I hear Dr. Brian Keating and about 10,000 other idiots just screaming at the top of their lung, just screaming out that Dr. Eric Lerner is a demon. They demonize him, but they can't answer his objection. So real science is happening, but your authorities don't allow it. They deny it, they fight against it, they'll do whatever they can to deny it. And if that happens to Dr. Eric Lerner, who's a plasma physicist for Christ's sake, what am I? What kind of a chance do I have against bigwigs? Big-ass, big-diapered, is wearing a crown of shit on their heads, and that makes them capable of calling me a know-nothing. I went through that in the church. I'm not going through it again. So this is a preemptive strike. Just like the Israelis in '67, I launch a preemptive strike against my avowed enemies who show no sign of restraint. Yes, your goddamn model has been overthrown, but not by Dr. Eric Lerner, because he doesn't have a better explanation. Not only am I overturning your stupid-ass theories, all of them, I have the better explanation in every case. A model that takes the place of your juvenile model. And if I get a chance to rub these men's noses in it, and I'm safe enough to do, I don't think that's going to be possible. Don't forget who backs these idiots. It's the United States government backs them. Because the United States government is a loser. So, what is the cause of redshift? Well, you're not going to find it in any textbook. Nobody actually knows. And do I know? I'm going to leave that up to you to decide if I know or not. I'm just going to tell you the evidence. But that's 47 minutes. And that's enough for one day. I don't know how you could enjoy this. I'm very disappointed. For days now, I've been trying to get into the, just give you the mathematics, the geometry, the answers. But I'm just going to be honest with you. You're too stupid. I'm probably going to have to take this to my grave. You can't understand this. It's just not possible. Is it easy? Yes. Is it correct? Absolutely. Should you want to know it? Yes. But do you want to know it? No. You wouldn't even know what to do with it if you did understand it, but you will block yourself from understanding it. I don't think there's any hope for you. But I just want you to know, it certainly put a lot of hope in my heart to get the right answer. Because I really, really feel cheated by our stupid-ass PhDs who just can't see straight. Because for the longest time, I looked up to them. I thought, well, I'll never be able to be like one of them because I'm just not smart enough. They're always going to be ahead of me, and I'll never understand what the hell they're saying. Well, once I was forced to look into it because I decided as a full-grown man around the age of 50, I'm sorry, but it did take me that long, and I realized, no, I have to stand up. I have to work. I have to get to work. And interrogate what is it that it seems so hard to understand that it looks like even you guys don't understand it. Although they swear on a stack of Satan's Bibles because they don't believe in God, so they can't swear on a Bible. I mean, it's like you find it, well, I'm going to look at it myself. I'm just going to have to look for myself. I'm going to have to do the work. I'm going to have to get serious. I'm going to have to go through the whole rigmarole, just repeat. Well, this is what a scientist does. That was the birth of a rational man who acts like it. It's one thing to have rationality, but if you don't apply it, what good is it to you? It's like knowing how to play, I don't know, some sport, but you never go out for the sport. In other words, you never use it. Well, I do have a brain, but it was very difficult for me to look at this stuff because I don't have a mathematical brain. I mean, it's in there. It's actually above average, but not greatly above average. Not enough to qualify for, high-end physics. I'm not even a candidate for that, okay? Because I can't do mathematics well enough. You have to be gifted. You have to be in the 99th percentile, and of those who are the top 1%, you have to be in the 99th percentile of them. Okay? To be in science at all, you have to be gifted. Well, that creates a problem, because then you get an aristocracy. That would not normally be as harmful as it currently is, but if you get a government to support your aristocracy at the expense of the commoners, just the regular citizens, you have a tyranny. That's what we have. I am a free man. I broke free of the tyranny. I got the answers that these men cannot get. I'll just say that just can't be expressed through the normal channels, because they own the channels, because the government owns the channels. So this is far-reaching. This whole scientific controversy about, for instance, the Big Bang, which has come up again because of Dr. Eric Lerner. This isn't all the news flashes. Doesn't last very long, though. It'll pass. Oh, the model is here to stay. It doesn't make any difference if the devil himself made the model. The model will live on because the government says so. That's called the image to the beast. We'll be right back. This is Anagalactic.